Hello guys, welcome back to Maths on African Motives. In this case, we are going to consider a typical exam question, which is a full paper revision, as we are considering our revisions for the March exam. So this is a March 2025 exam that you're going to look into, which was from the Mpumalanga province. And as we can see, it was our March test, and this was out of 58 and 70 minutes. All right, so these question papers, it actually depends with the province that you are from. We do understand that for the March test, you must be considering the topics that you have done in your term one. So that one also depends with your province, like I said. All right. So we are given our instructions and information. So make sure that you read each and every part of the instruction. And for the question paper, if you want to download this question paper, you can check the comment section, or you can even check the description of the video so that you'll be able to download the question paper, or you can even just check on the that is the drive for mathematics grade 12. If you check on the description of the channel, you are going to see mathematics grade 12 there, which is on the drive. So you can just get access to the drive, download any question paper that you see from there that is available. We'll just give you guys what I have. All right. So for those that you've got question papers from other provinces, all right, you are from another province, then you feel like we can have a revision, okay, from that province. You can even just send us pictures of that question paper so that we can work on that question paper as a revision here. And also, do not forget to join the membership so that you do not miss any of the other question papers that we are going to do. Some of the full papers, we are going to actually do them for the members, so that can help us. So like I said, before we look into our questions, depending with your province, some provinces, they are going to give you guys those basics of your algebra, all right? They are going to give you the part of what? Of algebra on question number one, meaning to say that part of your factorization, part solving of quadratic equations using factorization, the quadratic formula, all those inequalities. If we are to consider the part of our SEDS application of irrational numbers, the simultaneous equations, this and that. All right. So you must be able to answer that. Those are from your what? From your grade 11. So some other provinces, they do not consider that. All right. They will give you this part in your June examinations. All right. For those ones that you're going to write in June, they are going to give you this part of what? Of algebra. So like what we can see here, this was question number one. We do not have that part. This is what? Mpumalanga province. So we're not gonna waste our time. Question 1.1. Consider the arithmetic sequence. They told us it is what? An arithmetic sequence. You're already given. So you're not gonna test anything you're already given. All right. Determine the 36th term from what we are given, and this is what? An arithmetic. So in a case like this, we can even just simplify everything at once, as we do understand from our formula sheet. If we are given to find the nth term, we can actually determine from our Tn here of what? An arithmetic. All right, so that is what you're given. So in this case, it was a direct question. So as we've got our terms T1, T2, and T3, we are going to have this one as Tn is equal to A plus n minus 1 times what times d. So in case that you want to determine the Tn first, before you look into the question to say we are already given the number of terms, we do know that they are what? They are 36. You can find your Tn because you might need it somewhere in your simplification. So it is best also for you to properly see what represents your Tn. So A being our first term, which is 8, we have got that one. Our A is 8, then D. As the common difference, we are going to determine the common difference from our terms. Term 2 minus term 1, 15 minus 8, that is 7. Here there's also a difference of 7. So our common difference is 7. Let us substitute and find Tn first. So this is 8 representing our A plus n minus 1 times what times d, which is 7. So for someone, if you do understand what you're actually dealing with, you could have just inserted the 36 to say, okay, this is 36. Then you also put your 36 here. You simplify everything at once. All right. You're finding that term that you're given. But for the sake of other questions you do not know, maybe you might need to use that Tn separately. Now you have to calculate again. All right. So it's best for you to just determine it. All right. So let us expand, distribute by positive 7. So that's 7 times n, 7 times minus 1. But remember, there is a positive here, so that is not going to affect anything. So 7 times n, that's going to be positive 7n times negative 1, that's negative 7. So as we are to collect the like terms, we are going to have the 8 and the minus 7. So this is 8 minus 7, which is going to give us what? Which is going to give us a 1. So that is what we are going to have as our Tn. So therefore, if we are given our n as 36, we can determine T36. All right. So from this information that we are given, it therefore tells us that T36 is equal to what? In place of n, just put what? 36. So that's 7 times 36 plus what? Plus 1. All right, so that was it, guys. And if you simplify this on your calculator, that is 7, open bracket, 36 plus 1 like this. So that was going to give us 200 and what? 253, just like that. So we have this T 36. All right, so that is it. That is it. If you are to consider, I just need this Tn for the sake of revision. Let me just write it here. Tn is 7n plus 1, and our T36, we said it's what? 253. All right, no problem. Let us answer the other part of the question. 1.12. From what we are given, we are now asked to calculate on 1.12. Calculate the sum of the first 36 terms. Okay, so we do understand that in an arithmetic sequence, for us to determine the sum of terms, we can actually use this formula, which is very, very correct. We can actually use that. All right, no problem. But do also remember that we can also determine the sum of terms. All right, we can also determine the sum of terms of an arithmetic from n over 2 into a plus l. Knowing this formula, guys, can help you to simplify in an easier way. So I'm going to use the other one. No problem. I'm going to use the other one. Do not worry for that. Let me start with this one. On this formula, we just need number of terms, a, which is our first term, which we already have. So our a is our T1, which is 8. We already have that. Then L represents the last term. The last term, meaning to say from our Tn formula, which represents this one, this our Tn formula. Our last term will be on a condition that you're given to say the sum of the first 36 terms. Remember here, what did you calculate? You calculated T36 on 1.11. We already have that one. So our L representing our Tn is not just the Tn, but it is according to what we are given, because the last term must be what? 36. Must be at the n, which is 36. So that's T36, which is what? 253. So this will be T36, which is what? 253. So we have that one. 253. Why did I write A instead of 8 here? So this is 253. So as I have got the A and the L, I can simply use this formula because we are given for the number of terms being what? 36. So therefore, the sum from this formula that we are given can be determined. So that's S36. Remember, our N is what? 36. Is equal to 36 over 2 into A plus L, the first and the last. So our first is there, which is 8, plus the last term, which is what? 253, representing T36. Just like that. So with this one, you are simply going to determine the sum, 36 over what? Over 2. Then open bracket, we're going to have 8 plus 253. So this is what you're going to have, 4,698. So that's 4,698 as the sum of what? The first 36 terms. But this is not the only formula that we have. We can use the basic formula that we are used to and still obtain the same answer on our simplification. All right, so another way of answering this question to determine the sum, remember from our formula, n over 2 into 2a plus n minus 1 times d. We can simply substitute everything as we have got our a, the difference, everything. For how many terms? Okay, for the first 36, so 36 here, n is what? 36 over 2 into 2 times a. Our a is what? Is 8. So that's 2 times 8 plus n minus 1, which is what? 36 minus 1 times d. Our d is what? Is 7. So that is it. You are going to simply determine the sum. So simplifying this part inside the bracket, you're going to obtain 261. So it's 36 over 2 times 261, which was going to give us the same answer, 4,698. So as we can see, answering this question, you can work it from any way that you do understand. So that is how we can simply attempt these typical questions. All you just need, guys, is to be very careful with the formula that you choose to apply and attempt your questions from there. On 1.13, we are given, if it is given that T72 plus T72 minus M is equivalent to 786, determine the value of M for 3 marks. Okay, no problem. So you see what I was saying before. Say if you can simplify the Tn formula, it'll be best, because you never know what is at the end. So as we can see, we need that Tn for us to find T72 and T72 minus M. It'll be easier if you've got your Tn like that. Or still, you can even go back to that formula for Tn that you used before, a plus n minus 1. You substitute back, because you've got your n as 72, you can substitute. You've got your n as 72 minus m, you substitute there as 72 minus m. Still, it's one and the same. Or you can use the simplified formula for what? For Tn. All right, so let's consider 1.13. We do understand that we are given that T72 plus T72 minus M is supposed to give us what? 786. This is a given statement that you are supposed to apply or work on. So they told us about the statement. Now that we have got the Tn, let us substitute what we are given there. We can even simplify this on its own. We can simplify the T72 on its own if you're someone who wants to have it that way. So we can even have our T72. All right, remember from our Tn, which is 7n plus 1, so it's 7. Our n is what? 72. So that's 72 plus 1, like this. All right, so this is going to give us T72, which is 505. All right, so this is what you're going to have. We do calculate the sum, just like the sum here, T72 minus M. All right, so let's also do this one for T72 minus M, meaning to say in place of n, we are going to substitute 72 minus m. So that was 7 into what? In place of that n, we put 72 minus m. All right, so this is what we were going to have at the end, and there is a plus 1, remember. So if we simplify this, let us distribute by 7. We are going to obtain 7 times 72, which is 504. 7 times negative m, that's negative 7m plus 1. Collecting your like terms, as we can see here, we have got the 504 plus 1. So that was going to give us 505. Okay, minus what? Minus 7m. So this is T72 minus m. T72 minus m. So with these, we can substitute into our given statement. Remember, they gave us a statement here that if we combine these two, we must obtain what? 786. So now substitute those. T72, you have got the value 505. All right, so you're going to substitute that 505 plus our T72 minus m, which we obtained as what? 505 minus 7m. All right, so this is a plus. So if you are adding, guys, there's no need of you opening a bracket, just write as it is. All right, minus 7m is equal to 786. Now we can solve for m. As we can see, we have got a linear equation. So solve for what? For m. Collecting our like, we can even just add these two before we transfer these to the other side of the equation. You can just combine them as they are on the left hand side. That's 505 times what? Times 2, which is 1000 and what? 1010 minus 7m is equal to 786. Now we can get rid of this. How? So we can simply subtract this one. All right, so that is going to give us minus 7m is equal to 786 minus 1010 is going to give us negative 224. So divide by negative 7 by negative 7 here. Our m is going to be what? It's going to be a positive. So that was going to give us 32. 224 divided by 7 is going to give us what? 32. So we have got the value of m from the given statement. So you just have to be careful how the question is given. Answer the question according to how it is given. On 1.2, which is a continuation of question 1, we have got a given series. If you add this, it forms a geometric series. 1.21, write down the common ratio. We are already told, guys, it is forming a geometric where we do understand if we have got our terms T1 added to T2 to T3 and so on, the common ratio can be determined from T2 over T1, or we can use T3 over what? Over T2. We have got T2. So let us just substitute x minus 2 to the exponent of 3 over what? Our T1, which is x minus 2 to the exponent of what? Of 2. Remember, these are same bases. So as we deal with the same base on a division, we subtract the exponents. Remember the concept. So you're going to subtract 3 minus 2, which is what? Which is 1. So that was going to give us x minus 2 to the exponent of what? Of 1, which is simply x minus 2. So this is going to be our R. The common ratio is going to be x minus 2. Or you can even put that bracket. It is up to you like this. Or you can just have it as what? As x minus 2 direct. On 1.22, we are now given that determine the value or values of x for which the series will converge. They are telling us that for this series to converge, what must be the value of x? Because we can have other values of x which will make the series not to converge. But for it to converge, what is the condition? Remember our condition for our geometric series to converge. Our R is supposed to be greater than -1 but less than 1. So we are going to use that statement and see what will be the value or values of x. All right, so that's 1.22 for our series to converge. R is greater than -1 but less than what? But less than 1. So we have got our R in this case, our common ratio. We calculated this. So we are going to substitute that x minus 2 must be greater than -1 or less than what? 1 for this series to converge. So from there, let us determine our x values. -2 on x, how do we get rid of that -2? We simply have to add. So we add it 2, but for us to neutralize this, we are supposed to do it also here. We are also supposed to do it this side. So this is what you're going to have at the end. -2 plus 2, that's a 0. So we're going to have x, which is greater than, all right, here we add -1 plus 2, which is what? Which is 1. Here it's 1 plus 2, which is what? Which is 3. So these are the conditions that you're going to have. So here you oppose with what you're given. If it is a division, you multiply the other side. And also here, if it is a multiplication, you divide. So if there's a minus, you add. If there was a plus, we're going to subtract. You just oppose to get rid of what is affecting x at that moment. All right, so this is it. We are back to your inequalities. So as we can see, these are values of x. Any value in within this interval will make this series to converge. Any value of x in within this interval. So that was it on question number 1, having 10 marks for that one. As we can see, they do ask these questions. So you must revise, all right? You must revise. On question 2, we were given 2.1. The given number pattern is a combination of a quadratic sequence and an arithmetic sequence, a combined sequence, all right? So remember, we dealt with our combined sequence, which terms are given in order of what? Terms, to say we have got odd terms. We also have what we refer to as the even terms, all right? So let's consider what we are given on question 2, which is 2.1. These are the numbers. We are given 16, all right, followed by 32, followed by 0, followed by 28, followed by a negative, that's negative 12. So if you download the question paper, guys, you're going to properly see how it was given. As you can see, these question papers, guys, they'll be having a lot of things that we need to get rid of. So that is why we try also to edit these as pictures in this manner so that at least maybe we can see properly. But you can also check from the main question paper in terms of the presentation. So that was it. So the first thing is for you to figure out which one is the quadratic and which one is the arithmetic. So in most cases, if they give you in this manner, all right, if they give you in a manner like what we are given here to say it is a combination of quadratic and, it is going to be in that manner also to say the ones that are starting are quadratic, then arithmetic. But do not focus on this because they never specify to say in that order or respective. They just told us from these, there are two. But what we know is that whenever it is a combined sequence, whenever you are dealing with a combined sequence, the odd terms, they form their own sequence. The even terms, they form their own sequence. So you must be able to locate from the terms that you're given, T1, T2, T3, and so on. This is 4, this is 5, 6, 7, 8. You must be able to locate, to figure out which ones are the odd. Remember odd numbers, 1, 3, 5, and so on. It is going to form its own sequence. So for the odd terms, we can see that there is what? A 16, followed by what? A 0 there, followed by what? 5 there, which is what? Minus 12, followed by what? Minus 20, which is on what? On T7. These are your odd terms. For the even terms, these are the ones that are remaining. 32, we have what? 28. We also have the 24. We also have the 20. These are our even terms, 2, 4, 6, 8, and so on, 2, 4, 6. So we can see that the even terms are the ones for the arithmetic, as there is a common difference here, 28. By just looking into these numbers, guys, 28 minus 32, we can see that there is a difference of what? Negative 4 here, negative 4. So the even terms are the ones that are for what? The arithmetic. The odd terms are the ones for the what? For the quadratic, as we are given before. So whenever we're dealing with the odd terms, you know that is a quadratic. For the even, it is the remaining one, which is what? The odd, the quadratic, then the even are what? The arithmetic one. So our question here we're just analyzing, guys. This is just analysis of what you're given there. But now consider your question. Your question is 2.11, determine the general term of the quadratic sequence. So the quadratic sequence is the one that we are forming from what? From the odd terms, as I said here. This is the one that we formed from the odd terms. So from odd terms, let us answer this question, 2.11. So we need to find Tn of a quadratic, which is what? An squared plus Bn plus C. And this is from what? From odd terms. And these are our odd terms. Remember, we have got 16, 0, minus 12, minus 20. So our quadratic, guys, as usual, from our grade 11 mathematics, we're going to have the first differences. All right, so let us determine our first differences, as we have got T1, T2, T3, and so on. 0 minus 16, that is going to give us what? A negative in that case. So this is negative 16. Minus 12 minus 0, that is what? That is minus 12. minus 20 minus, like this, minus 20 minus, what are we subtracting? Minus 12. So it's going to be a positive there. And that was going to give us negative 8. Minus 20 plus 12. So we have got our first differences. Let's do the same to determine the second. You know our quadratic, guys. So that is minus 12 minus what? 16. Minus 12 minus, what are we subtracting? Minus 16. So just use your calculator as well. Minus 12 like this, we are subtracting minus what? Minus 16, so that you do not have any mistake. So that was going to give us a 4. The same thing, minus 8 is going to subtract minus 12. So on your calculator, you can even use this. Minus 8 is going to subtract. What are we subtracting? Minus 12, like that. So that was going to give us a 4. So as we can see, our second difference is the same. It is a constant, which is exactly what it is supposed to be like. So forming our quadratic, we know that this is supposed to be equivalent to 2a, our second difference. The first term of the first difference is supposed to be equivalent to 3a plus b, and our first term t1 must be equivalent to a plus b plus what? Plus c. And they are all available. So it's a straightforward question when it is like this. Let us equate. 2a must be equal to what? To 4. Divide by 2, so our a is going to be a 2 there. All right, let us move on to another one. 3a plus b. So we know that 3a plus b must be equal to what? Negative 16, which is our a is what is there as 2. So that's 3 times 2 plus b equivalent to negative 16. This is going to give us a 6. So b is what? Negative 16 minus 6 if we take it to the other side. All right, which was going to give us negative 22 minus 16 minus 6. Then if we do this for finding the value of c from the first term, a plus what? A plus b plus c is supposed to be equal to t1, which is 16. So we have a and b. So that's 2 plus minus 22, our b is a negative, plus c, that must give us what? A 16. So let's try to simplify 2 minus 22, that's minus 20 plus c. So c is equal to what? 36. If we add 20 there, that was going to give us 36. So with the values of a, b, and c, our Tn can be determined. All right, so let us quickly substitute what we are given. Our a, that is 2, n squared. Our b, negative 22, n, plus our c, which is what? Which is 36. So this is our Tn, which is from the odd. So it's T odd. Remember, this quadratic is from what? From odd terms. From what? From odd terms. So we have that. Let us determine the other one. The general term of the quadratic, all right? So we obtained this one. Our Tn, 2n squared minus 22n plus 36, in case that we might need to use that one. So 2.12. For the quadratic, we were done. Now it's arithmetic, which is what? The one that we saw here for the what? The even terms. They are the ones that are forming what? An arithmetic. So we are simply going to determine, there is actually a clear part, because our Tn for an arithmetic must be given as what? A plus n minus 1 times d. So we have got everything. For these even terms, our first term is 32. So we're going to substitute that one. So that's Tn is equal to A, which is 32 plus n minus 1. All right, so that's n minus 1 times d. Our difference, we already saw this is what? Negative 4. For us to say it is an arithmetic, it is because of this negative 4. the common what? Difference. So simplifying our Tn, that was going to be 32. We multiply, guys. This is positive and a negative. So it's going to give us what? A negative. So the positive actually are not useful. So negative times this is going to give us negative 4n. All right. Negative 4 times negative 1, negative is going to be what? A positive. So that is it. We can even simplify this. That's Tn is equal to minus 4n. Let's add our constants, which is 32 and what? And 4. So if we are to add these two, that was going to give us what? A 36. 32 plus 4, that is what? That is 36. So we have our Tn as minus 4n plus 36, which is representing what? An arithmetic, but that is what? For the even terms, remember. So we have this one. Minus 4n plus 36, all right? No problem. Now considering 2.13, which is a part that is very, very important for us to understand here. 2.13. They are saying that the given number pattern has two consecutive terms that are equal in value. Two consecutive terms that are equal in value. What type of a sequence is it? It is a combined sequence. Determine the positions of the two terms. All right, guys, from the word consecutive there, we are following a certain manner or a certain order. In that manner, there are two numbers following each other, just like this is T1, T2, T3. They are numbers which are exactly the same, equal. Maybe this is 20 and T3 also is a 20. This is what they mean. Consecutive terms are equal in value. They are following each other. T2, T3 following each other, but they are equal in value. So if we consider to say what we are dealing with here is a combined sequence. So one of the terms definitely, guys, is going to be odd. There is no way. And another one is going to be even. There is no way. We cannot say the terms they are following each other. 1, 2, 3, 4. There is no way that we have two numbers, consecutive numbers, whole numbers. We're talking about whole numbers. 1, 2, 3, 4, 5. Then they are both even or they are both odd. That cannot happen. What I'm trying to say is that 1, 2, 3, 4, as our terms say, this is T1, this is T2. There is no way that we can have T3, then the following term is also an odd to say maybe this is like T5. There is no way. For two consecutive terms, for the whole numbers, because you're considering whole numbers there, one has to be odd, the following even. If one is even, the other one that is following is supposed to be odd. If we've got 2, the following number is what? 3, which is odd. 4, the following is 5. So we cannot have both odd or both even terms. It means one of the terms, we are talking about terms here, one of the terms must be odd and the other one must be even. But they are equal now. That odd and even term, they are what? They are equal. This is what we are told. So 2.13, whenever we are having these terms, whether we have got the odd as a static or we have got the even that is following, but for that condition, they said they are equal in value. So the T representing odd must be equal to the T representing even, the term. So what is that term representing the odd? Remember, odd terms are those ones forming a quadratic, which is this one. So the Tn there 2n squared, which is from our quadratic, minus 22n plus 36 must be exactly equal to what? To that one for the even terms, which is the arithmetic, the one that we got as what? Negative 4n plus what? Plus 36. This is what you're saying. The odd term in that sequence and the even term in that sequence, they are the ones that are equal. So you equate them. You are told that those two consecutive terms, they are equal at that moment. So you have formed an equation that you are going to use to solve for n. Here, we are not solving for the position. We are solving for the n that will give us the position. Take note here, they said, determine the positions of the what? Of the two terms. So the n that we have here is the n that will tell us the position. Always, when they ask you for this type of a question, guys, when they ask you for a position where the term is, you determine the n, then position, you say for all the terms, always the position for all the terms is given as 2n minus 1. If they are even, if you find out all those even terms, 2, 4, 6, their position is always 2n. So here we are finding the n that will give us the exact position. This is the condition of n when the terms are equal. But for us to determine the position, we come back here. So be very careful. This is the n, so we can even put this one in terms of k, so that we do not have a confusion. We can just say our k here representing odd, our k even. But as long as you understand what you're writing, guys, there's no need for you to write k or m or what. Or you use your k here, then you use your n this side. It is up to you, or you can just solve. Since you are used to n, let me just work out the n. So here we are going to solve this, then determine position later on. A quadratic equation, one of the sides must be equal to 0. So we are going to take the terms on the right hand side to the left hand side and see what we are going to have there. 2n squared minus 4n, this side is going to be a positive. So it's minus 22n plus 4n, a positive. So that is going to give us minus 18. Minus 18n. 36 to the other side is going to be a negative. So it's 36 minus 36, which is going to give us what? A 0. So there's nothing here. Okay, so this is it. As we can see, there are two terms. There is no need of you even using quadratic formula. Just factorize two terms, guys. All right, factorize. 2n is common. That's our highest common factor. So 2n squared divided by 2n is going to give us n. 2n squared over 2n. This cancels. Here it's 1. Here there are 2. So you're going to remain with 1n. Minus 18n divided by 2n, like this. So this and this is going to cancel. That's negative what? Negative 9, which is equal to 0. Remember the zero product from your factorization. As long there are two terms multiplied together to give us a 0, one of these is supposed to be equal to what? To 0. 2n must be equal to 0, or the bracket of n minus 9 is supposed to give us 0. So that's it. We solve here. Our n is going to be 0. Or if we solve on the other side, taking the minus 9 to the other side, n is going to be what? Positive 9. We are talking about the position to be found from the value of n. So there's no way, guys, we can use 0 there. All right? There's no way we can use 0. So n cannot be equal to 0 in terms of our simplification, because we need the position. There's no position like 0 position. We must have first position, second position, third position. So the value of n, therefore, that we are going to use is 9 to give us the position. To give us what? The position of these consecutive terms. So we are now using that condition. Odd terms are given by what? Odd terms are given by 2n minus 1. Even terms are given by 2n. So therefore, our position. We can just even, let me just substitute here, guys. So that's 2 times the value of n, which is what? Which is 9. So minus 1. 2 times 9 is 18 minus 1, which is what? 17. For the even terms is 2 times what? 2 times n. Our n is what? Our n is 9. So that's 2 times what? 2 times 9, which is 18. So those are the position of our terms. We are saying, therefore, T17 and T18 from that original sequence are the terms that will give us what? Are the terms that will be equal. So we are simply saying these are the terms that are equal. Are equal in what? In value. So if I am to substitute according to that arithmetic, I substitute that n, which is 18, on that quadratic, our n, which is 17. The values must be equal for the what? For the given condition that we are talking about. So those are the positions where the terms are given in terms of the original sequence. All right, in terms of the original sequence. So here, guys, this is about the from the original sequence. But for the values that you, if you want to actually test the values now, you go back with the n here that we had before, because this n is now bringing us back to say, what exactly are you dealing with? Not here. So if we use the 9 on this condition, you are going to find these two be equal if our n is 9. But remember, this is the position which is not exactly according to the original sequence. A combined sequence, actually, I'm not supposed to explain much here because, guys, we've got the introduction of this. Remember, a combined sequence, its terms, all the terms in the combined sequence are not the way that you use them when you are to calculate your Tn. When you find Tn, you use Tn according to the sequence that you are working with. The Tn for odd terms, you must consider for odd terms only. The Tn for the even terms, you must consider the even terms only. But they are the ones that are combined to give us that whole sequence. So they won't be a formula that you're going to say, okay, this is the formula for the combined sequence. No, you separate them. Odd terms, even terms, like that. So it is the same thing even for the position. After finding n, you separate them in that manner again, because there were two of them for odd and for even. This is what I'm trying to say here. So meaning to say, for your position, your odd terms, this is your formula. For even terms, this is your formula. And remember, even 2, 4, 6, just in that manner. With these, guys, you won't go wrong. You won't go wrong in answering these questions, all right? So this is what we have as our final answer, all right? Let's consider the other part of our question, which is given, all right? So this was 4 marks, and 2.2, which is part of our we are given, this is going to form a geometric there, but it is a summation. But as we can just, by just looking into the question, guys, you must know, guys, this cannot be an arithmetic with this exponent. The exponent there, this one, that exponent on its own is telling us something. Even your R there, you can see this is your R there, which is what? -3. There's no need of even you working a lot of things. But anyways, for the sake of revision, we are given to calculate this for 4 marks, all right? So that's 2.2. We have got a summation from k is equal to 3 up to 9, and that's 2 into -3 to the exponent of what? Of k, all right? So we can see that this is a geometry, guys, by just looking into our summation, we can see, all right, this is a geometric series that we're going to form from the terms that were being added. But what is that? The first term and so on, because on a geometric, we do understand the sum, summation, sum of. So Sn is given. All right, I have been working with the extensions of the formula, but anyways, guys, most of you want to use this formula, only this one. So let us just use that one and see. All right, a into r to the exponent of n minus 1 over what? Over r minus 1 is the sum of terms for a geometric what? For a geometric series that we are given. Where our r is given, guys, that is if you... Okay, let me just do this, but you'll see that your r is -3. Let's say you find your first term when our k is what? When our k is 3. It's going to be 2 into -3 to the exponent of what? Of 3. You simplify, that was going to give you a -54. You do the same thing, your t2, 2 into -3. Our k is increasing from 3 going up. So it's now at what? It's now at 4. It was 3. Now it's what? It's 4. So if you simplify, this was going to give you 160, 162, and so on. So you're going to form that, and so on and so on. Then you can divide these two second term to the first term. Guys, you're still going to obtain that -3. But anyways, this is it. How many terms are we going to use from this 3 to +9 on top? From 3 to 9. How many terms do we have? So our n is going to be what? 9, the top minus the bottom, but do not forget to add 1. So this is it, 6 minus, from this we're going to have a difference of 6, then we add 1, that is what? A 7. So there are 7 of them. So that's S7. N is 7, is equal to A, your first term, T1, -54. Remember I told you guys, a summation is just sum of. So sum, you must go back to the sum of terms. And for the sum of terms, as long it is a known sequence or series that you have, sum of terms is there. If it is arithmetic, you have it. If it is geometry, you have it. All you just need is to tell, is it an arithmetic? Then you use your arithmetic. Is it a geometric? Then use the sum of terms for what? For geometric, just like that. The summation does not answer the question. It is the formula corresponding to that series formed. Just like that. All right? So with this information, we're going to substitute our r. Remember, that is what? -3. So you're going to have -3 to the exponent of n, which is 7 minus 1. Everything over what? Everything over r minus 1. Our r being what? -3. So we're going to have -3, negative what? -1. So this is the condition that we are going to have for the sum of terms. So that is the simplification of that whole summation that you're given. This evaluation of this summation is into this. So it is the one that you're simplifying. You can even just use your calculator at once here. You have your fraction, -54. All right, let's open bracket, then open another one for -3 to the exponent of what? Of 7. All right, then we're going to subtract 1 and close the bracket on top. Then in the denominator, that's -3 minus 1, which is what? It's going to give us a negative. So that's negative 29,500 and what? 538. 538. So this is it. You have determined the summation of that whole question that you're given. From that statement alone, you must figure out the series formed. Is it arithmetic? Is it geometric? From the format, guys, if you see these exponents, that will be your geometric. And the part that is raised to the exponent here, the part that is being raised to a certain exponent is your what? Is your r. All right. For a linear, guys, for an arithmetic, remember arithmetic is linear. So from your revision also you must tell what are you given. A linear, if it was something like maybe a summation, then we've got 3 plus 2n. 2n, 3 plus 2n. We know that that will be an arithmetic. For whatever condition that will be given there, we know that this is arithmetic. But these exponent, a certain part, raised to a certain exponent, geometric. So you can even have your terms T1, T2, T3. Then you test if you still have a confusion to say which is which. You can find terms, find them, 3 terms. Then you can tell from 3 terms, is it geometric or is it what? An arithmetic. So that was our question 2. Having what? 14 marks. Let's consider question number 3. On question number 3, it was part of our functions and what? Functions and graphs. Where we are given 3.1, given this f of x, which is x minus 1 squared minus 9. That's a parabola that we have there. Given in the turning point form. Remember your TP form where f of x is equal to a into x minus p squared plus q, where the point PQ represents what? Your turning point. It's a turning point form. So anyways, they say 3.11, determine the turning point of what? Of f from the PQ. So as we can see, it was negative, it changes to positive. So whatever value of x that is there changes to a positive. The sign changes. So you can just equate to 0 if you do not want to have confusion. So x will be equal to what? 1. So that's our turning point. X is 1. The y value is not affected. Q, this is still our Q. The y value is not affected. That's it. So this one, guys, is just knowing the format that you are given. All right, then 3.12, write down the equation of the axis of what? Symmetry of f. The axis of symmetry, remember, for any quadratic function at the turning point, the value of x represent what? Represents the axis of symmetry. So as we have got our turning point at what? At 1 minus 9, the value of x represents the axis of symmetry. So x is equal to what? X is equal to 1. Write down the range of f from this graph. From where? From the turning point. The y value determines our range. The y value determines our range. So if you're going to say expanding this was going to be x squared. Remember, when it is x squared, if you expand the x squared, when it is a positive, it means our graph is going to be what? Concave up like this. So meaning say it has a minimum turning point. So the y value at the minimum turning point is the one that we are given there as what? -9. But this graph, it is going what? Up. From -9, it is limited from -9 at the what? At the turning point going up. So therefore our range y must be greater than or equal to -9. Or equal to -9 is part of the function, is there at the turning point. All right, so this is your condition that you must have. Or we can simply say, we could have just written as from what? From -9 going up to where? Up to infinity, it does not end. All right, and this y must be what? Any real number. Just like that. The range, the y values from the turning point. So you must tell, guys, the function, is it concave down? Where there is a turning point, you're going down. So y is less than or equal to this when it is like that. But for a concave up, y is limited here going up. So y must be greater than or equal to the value at the what? At the turning point. You must tell the type of graph that you're going to have. Is it concave up or down? From what? The coefficient of x squared. If you're going to expand it, it was going to be positive x squared. On 3.14, calculate the y-intercept. Calculate. It is different from this. Write it down. Right? There you can just write the answer. There's no calculation. But here there's something to be done to determine the y-intercept. What is the condition? For each and every concept of the y-intercept, guys, x is equal to 0 in the y-axis. Any point that lies in the y-axis, x must be equal to 0 there. So 3.14, that is the condition that we are going to use. For the y-intercept, x must be what? X must be 0. So if x is equal to 0, substitute into the original function f of x. Y is equal to what? In place of x, that's a 0 there. So that's 0 minus 1 squared. Do not forget to square it. Minus 9. So that was going to give us the y value by just using your calculator. 0 minus 1, we square it, but do not forget to subtract a 9. That was going to give us what? Negative 8. So y is negative 8. Where x is what? Where x is 0. So therefore, our y-intercept is going to be given as what? 0 minus 8. We have it as a point. This is the condition, right? Just like that. You're done. Just like that. Calculate the y value. When x is 0, you substitute as a point, x versus y. So that was it for question 3.1. For 3.2, consider the function gx given as x squared. What transformation did the graph of f of x undergo in order to obtain the graph of g? What transformation? We are back to transformation. I have already placed a playlist for you guys for transformation for your grade 12 mathematics of the basics. So make sure that you go through that playlist to understand everything that you need in your transformation. So here we are given something, f of x. Yes, to transform, it undergoes a certain, or maybe transformations. Cannot be one, they can be two, they can be three, depending with what you give. To give us, or to obtain what? Gx. So what actually happened? We need to figure out from f of x, from that f of x which is given as x squared, that's x minus 1 squared minus 9, to give us a graph which is now gx. And our gx is what? Our gx is x squared. That's our gx, x squared. What happened? You figure out, remember your transformations, guys. We listed all of them that are necessary in your syllabus. So in this case, we want to see what actually transpired, because we are just left with x squared, guys. Look, what happened with the negative 9? The y value, the negative 9, it is no longer there, meaning to say, for us to neutralize, to get rid of this negative 9, what happened? We added a 9 there, minus 9 plus 9. So it's a transformation, this one. Adding 9, adding a constant to f of x, you add a shift of a units going up. 9 units going up. We've got a shift of 9 units there. Going up. F of x plus a. F of x plus what? Plus 9. On our f of x, we added a 9. We took our f of x as it was. We took it x minus 1 squared minus 9. Then what is it? Plus 9. F of x. This is your f of x as it is. Then we added a 9 to it. We neutralize that. We no longer have that. So there is a shift of 9 units going up, which we can visibly see from that. 9 units up, a shift. A shift of what? 9 units up, positive, upward, going up as it is. But neutralizing this is not giving us x squared, because there is x minus 1 squared. So when we neutralized, when we shifted the graph 9 units up, the graph was now left as x minus 1 squared, not x squared. So what happened here? What happened to get x squared? what happened? In order for us to neutralize this negative one so that we remain with x and x squared, which is this one, what are you going to do? It means in place of x here, this is what happened. In place of x there, we substituted it to give us this x squared. We substituted in place of x, we substituted x plus 1. So that if we have x plus 1 representing x, but already there is a minus 1 which is on our question here. There is already a minus 1 on our question. It was going to give us what? 1 minus 1, which is what? Which is 0. So it's x squared, and x squared is still x squared. So this transformation of substituting x plus 1 in place of x, what is it? Which transformation is that one? You have your x, but you substitute x plus 1. It is f of x plus 1. In place of x, put x plus 1. But as a transformation, how do you describe this? X plus a. Remember guys, how do you transform this? We dealt with this type of a transformation when we are shifting a units to the left. This is a horizontal shift. Here we're dealing with a vertical shift affecting the y value. But here we are affecting the x value. Remember, x, when it is f of, it opposes the meaning of what is happening. So if it is a plus, it means we are going to the left. So plus 1, this one, it means we are going to the left. This is the one that neutralized our minus 1. We substituted x plus 1 there. So this f of x plus 1, this one, it's a transformation that happened. It's a transformation, which is the one that we are talking about here, that it is what? It is a shift. So we also have and a shift of what? 1 unit to the left. A, it means plus a, it means to the left. So that is of 1 unit to the left. 1 unit to the left, or you can just say leftwards. That is to the what? To the left. Horizontally to the left. We have neutralized it to x squared. So the question is, what are you just figure out what happened? What is it that I'm going to do to make it be x squared? Get rid of this. But after that, you see there is x minus 1 squared. What happened? You substitute x plus 1 to get that x squared. So those are the two transformations that occurred. So we're going to answer with this: a shift of 9 units upward and a shift of 1 unit to the left or leftwards. You have answered your question. All right, let's figure out the other part of our question. You just have to be careful, guys, when answering these questions. As you can see, it will be a little bit direct, and with revision. All mathematics are all about revision, guys. Maths is all about revision. Restrict the graph of G such that the inverse of this graph is a function. All right, the graph of G is this one. We do understand that when you find the inverse, there is going to be y is equal to square root of x, which will be something like this. So it won't be a function. It will be a what? It will be a relation where it crosses the vertical line, passes at what? 2 points, crosses 2 points on your graph. So to restrict, it means our x values must be separated, to mean we can work with x values that are less than 0, negative values, or we can work with positive. That is how we can restrict. We can work with either positive, or we can choose to work with negative. Even here, because we'll be saying, okay, let us choose to say our y value is supposed to be what? To be positive or negative only. But those y values were affected from what? From gx as what? As x. This is the inverse, remember. But they do not want you to restrict the inverse. No, they said restrict the graph of G here. So you are not restricting y on g. You are restricting x to say if our x in the original sense was a negative value, a value less than 0. But the origin, guys, we cannot consider that because the origin, whether our graph is like this, the origin is just the origin. So it can be less than or equal to 0, or for positive values greater than or equal to 0. So our values can be negative or our values of x can be positive. In that way, the inverse won't be a relation. It will be a function because you'll be just working with one set of values of x. So it will give you one set of values of y. Because if you work with the both sets like you work with both, your y, your x values there, if you consider here, you now have both y values on your inverse. Here I'm talking about the inverse. So you restrict it back when it was gx before its inverse. All right. 3.23, determine the inverse now. Now they want you to find that. Include all restrictions now. So there we are dealing with the inverse. So how do you find the inverse, guys? Remember, the inverse is when you transform the original function in the line of y is equal to x. So this is where you interchange, right? 3.23, y is equal to what? X squared. So we interchange x and y first. So we have to interchange x and y. That's x is equal to y squared. Then we make y the subject, make y the subject. So if we make y the subject, it is squared. So how do we get rid of the square? We introduce the square root. So y is equal to the square root of x, which we do understand that the square root of any number is plus or minus. That is where we are obtaining that relation concept, all right? So this is what we are going to have as our inverse in the form of what? Y. So y is equal to plus or minus the square root of x. Where for this graph now, our x under the square root now is limited now from 0. So x is greater than or equal to 0. X under the square root, we cannot have the square root of negative values. Remember, square root of -1 does not exist. So we start from what? We start from 0 going up. From 0 going up, square root of 1, and so on and so on. So this will be your restriction. But that here, it is not a restriction of it to be a graph. I mean, for it to be a function. It will just remain as a normal graph, as a relation, not as a what? Not as a function. Because y is equal to square root of x, guys, is going to be something like this. So it won't be a function because of what? The vertical line test. But that is not about our question. 3.23 is not about that. 3.23 is about finding the inverse, include all restrictions. Now for the x value cannot be a negative value. All right, so that is how you answer these questions for 12 marks. And question number 3, as you can see, for 12 marks, we had this part. So you just have to be careful how the questions are given and so forth. Be very, very careful to consider each and every section. On question number 4, they gave us the graph below shows us, the diagram below shows us the graph of what? Kx, a to the exponent of x. The point B is also given as part of the graph, which lies on K. It's a point which is on the given graph. So from this diagram, 4.1, they are now asking us to show that our A is 3 over 2. So it's a calculation already made for us. We just need the answer to show it. From where? A point which lies on the given graph. So that is the condition that we can simply use x versus y there. 3 and so from point B, which is 3 versus 3, and 3 over 8 can be written as you put this one, shift, you put this fraction, all right? So it's shift first, you must have that shift here, then you put this fraction. So it's 3 and 3 over what? Over 8. So this is equal to 27 over 8. So that's 27 over 8, this one. So from this point B, we have the x value and the y value that can be substituted back in our kx. Thus, y is equal to a to the exponent of x. So the y value, 27 over 8 in place of y, is equal to a to the exponent of x. Our x, which is what? Which is 3. We need to calculate the value of a, remember. So how do I get rid of the 3 on the exponent? The cube root has to be inserted, the cube root. To get rid of what? The cube. You introduce the cube root. The cube root, both sides. So this neutralizes. We have got our a as the cube root of 27 over 8. So the cube root, shift, you put the square root, that is shift on the square root there. Then you can put your fraction 27 over what? 27 over 8. So that's 3 over 2. And there are some who have been saying on the comment section, I do not have a calculator, this and that. Guys, if you are doing pure mathematics, there is no way you must have a calculator. Some of the calculations, they are based or they are limited to the calculator. So make sure it is a scientific, the one that is required. All right? Not just any calculator. You just pick any calculator, then you start to use it for mathematics. Some calculators are not meant for pure mathematics. They are meant for those ones who are doing maths lit, which is just addition, subtraction, multiplication, division. But for complicated, you must have a designed scientific calculator that can be very best. All right. Anyways, that is our value of a. We managed to show that and draw the graph of h, the reflection of what? Of k, and the line y is equal to x. As long we are having a reflection in the line y is equal to x, we're talking about what? The inverse function, showing all the intercepts with the axis and the coordinates of another point on the graph. So the inverse is the one that we have. The line y is equal to x, we must be very used to this one, guys, for the line y is equal to x, all right? Just for the sake of time, this is what we're going to have. The line y is equal to x, let me just put it in a broken line. It passes through the origin, dividing your graph into 2 equal parts. This is how it does. It divides our graph into 2 equal parts from the origin, like that. So let's say this is y is equal to x, somewhere there, something like this, all right? Let's say this is our line y is equal to x. I'm going to use the original graph that you're already given here. So we have got y is equal to x. Reflecting this graph, we are going to have it on the other side. This piece is going to be found on the other side, on the negative region, tending to approach the y-axis, but it won't approach that y-axis. So it will be like this. The one here will be reflected to the one horizontally here. Remember the concept. So it's going to be like this. Then as you can see, guys, this shape is the one that is just going to be reflected the other way around. So this is what you're going to have. So 1 here is the one that you're going to have on the x-axis. The same, this point is going to be shown maybe somewhere here. But what happens, remember what I said, guys, a reflection in the line y is equal to x. You swap coordinates. So you're going to swap these x, y. This is your x, this is your y. So this is going to be yx. You swap them. So it's 3 and 3 over 8. Then the x is now our y value, which is 3. So you swap coordinates. Remember, a reflection in the line y is equal to x. I talked about this on your transformation. Check the video on transformations. You swap. If it is line y is equal to minus x, you swap, then you change signs. You change both signs. But y is equal to x, you just swap. No change of signs. You just swap them. So this is the condition. Here it was 0, 1. So you swap them. Here it is now 1, 1, 0. Just like that. So this is how you transform your points along the line of y is equal to x. All right, we want to consider another part here. I just used the original graph that we had before, no problem. Then 4.3, write down the equation of what? Of h. There we are just being given to draw it, to draw the h. This is our k, this is our h, the one that was a reflection in the line of y is equal to x. Now they want you to have its equation, which I said it's what? It's the inverse function, guys. As long we are reflecting in the line y is equal to x, it is a reflection that you are determining. It is the inverse function. They are simply say find the inverse of that kx. That is what they mean. Or you can have any other way that you do understand. So remember, this is what we had. So that is from here, from our a that we calculated. Remember, it was 3 over 2, this and that. So it means our kx originally, if we substitute our a, which is 3 over 2, is 3 over 2 to the exponent of x. All right, so this is it about our question. They want us to determine the equation of hx, all right, on our question 4.3, where hx is the inverse of what? It is the inverse of what? Of kx. That is the inverse of k. So simplifying the inverse of what? The inverse of k. Remember how to determine the inverse, guys. First things first, you interchange your x and y. You must interchange x, y. So therefore, we're going to have x is equal to, here is going to be what? 3 over 2 to the exponent of y. You interchange first. Someone can even just leave it like this. It's fine. It's an equation, isn't it? It's an equation. It's a function. You can even leave it like that. But in most cases, you have to make y the subject. So after interchanging, make y the subject. So make y the subject from an exponential where y is on the exponent. Once you see this, remember the conversion of the logarithmic of x in the base of a, which gives us y. It can be in the base of b. It can be any base, whatever that you want. So it follows that this x is equal to b to the exponent of y. X here is equal to this to the exponent of this. You're done. So meaning to say, from here, I can convert it back to a logarithmic. X is equal to a certain base to the exponent of y. It tells us that it must be the logarithm. We are now converting to log. The logarithm of what? X, this one. Our x in the base of b, our b, the base. What is our base? 3 over 2. This one. This is our base. So that's the base. 3 over 2 must be equal to y. What represents our y is the exponent, and that is the y that we can see there. So y is the subject. Remember, when you talk about functions, guys, it's easier to say y is equal to. Y is equal to. So y is equal to what? The logarithmic of x in the base of 3 over 2. So that's our hx. As we said, hx is the inverse of what? The inverse of what? The inverse of k. So therefore, our hx is equal to the logarithmic of x in the base of 3 over 2. As you have got in the form, writing in the form, y is equal. Didn't they even mention that? Right here they just said write down the equation of h. So if they mention to say in the form y is equal to, that is the simplification. So someone can even leave this answer at this stage because they did not mention to say in the form y is equal to this. But if they mention to say in the form y is equal to, this is the form that they want as a logarithmic. So it is best that you just simplify in the simplest form because that you must be used to that. There is no way you must be used to that at the end of the day. And this conversion, you must be used to it at the end of the day. So this is what we have. This is what we have. All right, let me just leave this one. We might need to use it later on. On answering this other part of the question, write down the value of values of x for which h is less than 3. H, the one that we just determined on 4.3. This is our h. So they want values or the value of x that our h is less than 3. So you just take it as it is the logarithm of x in the base of 3 over 2 must be less than 3. 1, as long you are dealing with a log, the x is limited in such a manner that we already know our x must be always greater than 0. The logarithm, guys, we are dealing with the logarithm here. Know the concept. 3 over 2 as our base, and this is a logarithm. We cannot have the logarithm of a negative value. That cannot happen. We cannot have the logarithm of 0 here. It cannot happen. It starts for values that are greater than 0. It can be 0.1, it can be 0. We can have values, as we can say. Log, that alone to say it's a logarithm, a logarithmic inequality that we have there. It limits your x on its own. X must be greater than 0, not equal to 0. No, you cannot obtain the log of 0. Not that. So it must be greater than 0. So we are now limited to the second condition now to say when it is greater than 0, therefore the same x must be certain less than to a certain value, which is the critical value according to our inequality now. Here, that will be our critical value. So the critical value, remember, finding critical values or the critical value is solving for x. Remember that. It is solving for x direct as an equation. How do we form an equation from here? Remember that conversion that we had before. From a log to an exponent. From an exponent form to a log. So we do the same. There we have got a log. So we take it back to say this x must be equal to what? To the base, to the exponent of the answer. The base. 3 over 2 to the exponent of your answer. So you solve it as an equation. For critical values, it will be like this. Log x base 3 over 2 is equal to, you put equal. Remember, when you're solving critical values, guys, there are two brackets, x minus 1, x plus 2. You say is equal to 0, x is equal to 1, or x is equal to those. That is like an equation you are dealing with. All right? So that's 3 over 2 to the exponent of what? To the exponent of 3 here. So we can solve for x. And from this part, our x is what? 3 over 2 to the exponent of 3. That's 27 over 8, isn't it? 3 over 2 to the exponent of what? Of 3. That is going to give us what? 27 over 8. So 27 over 8 is another value of x besides the critical value of 0. Besides that one, 27 over 8, which we see from the direct inequality. But like I said, we are talking about conditions of an interval between these values, that x must be greater than 0, but less than what? The critical value that we obtained by solving that logarithmic equation, which is 27 over what? 27 over 8. We are dealing with a logarithmic. So we have an interval within the given value of x. Just like that. Revise, guys. Grade 12, you take everything, every mathematical concept is important from what we have done from grade 8, from your grade 8. Every mathematical concept that you learned there was not a mistake, or it was not just for joking around. It was something to be used, which is what we can see now. Those exponents, those logarithms in our grade 10, grade 11. Do revise those basics again. Your inequalities, a basic approach of what is an inequality as a basic approach as you are doing, because these are revisions. So also the basics are needed, all right? So as an individual, let's do revise, guys. We need more questions before our examination, before you attempt your final examination. Try by all means to do revise as many questions, because some of these questions, they do repeat now at the end of the day. You're seeing what you have done from this question paper is the same as what you're doing in another question paper. So the more you do revise this, and for the sake of revision, now that you are preparing to say, okay, this is for a certain province, this and that. But for the final, guys, they combine everything. You're not going to be saying, I am from this province. I am from this province. No, it's a final that you have at the end of the day. So do revise even from other provinces. Go through them. Check how do they ask there. Be equipped. Be equipped to know almost everything that is happening in your mathematical world for that moment, because that is your last session for your high school. So there's no way. You need to understand in as much as you can to say, if you are done with it, you are done. So let's do revises, man. We're going to check our question number 5. So if we consider this part, we are given 5.1. There we are given the sine of 36 degrees, which is equal to m. So determine cos 36 in terms of what? In terms of m. So there are actually so many ways to answer this type of a question, especially when you have a sine and a cos of the same value. Remember your Pythagorean identities, which can be the easiest way in order for you to answer this question. If you know that the cos squared of x plus the sine squared of x is supposed to give you a 1. Since we are referring to the same angle, so you're going to have another way. There are actually so many ways that you can use. So this is the same angle there. As we can see, is 36. This is also what? 36. So you can even just substitute that what you are given. What does it mean? It simply means we need what? Cos squared from what? 36 degrees plus the sine squared of what? 36 degrees. This is supposed to give us a 1. But we have the sine of what? The sine of 36. We are given this one. So it is going to be cos squared 36 plus the sine squared, representing the sine of 36. We put m. So that is going to be m squared, sine squared. So that's m squared, which is equal to what? To 1. Since our cos is needed in terms of m, we are in the right direction because we have our m. So you're simply going to make cos 36 the subject. So cos squared 36 degrees is equal to what? Subtracting m squared, or taking that m squared to the other side, that was going to give us 1 minus m squared. So get rid of the square that you're given, knowing that you're going to have what? The square root. That is the cos of what? 36 degrees. Here, the square root to get rid of what? The square. So cos 36 will be equal to the square root of 1 minus m squared. So we can actually attempt this one in a direct way as we understand our Pythagorean identity. So this is it. Or some of you guys, you are used to the application of what? The quadrants, where we have the angle there. 36 is an acute angle, which we are going to find basically in the first quadrant as an acute angle. So this is according to the ratio of sine from our SOHCAHTOA concept. We do understand sine is opposite over hypotenuse. So the sine of 36, it must be m over what? Over 1, so that we can properly see the opposite over hypotenuse concept. So this is our 36 degrees. This will be our opposite and hypotenuse. So we've got opposite, hypotenuse, and this is our adjacent. So that is our opposite is M and hypotenuse is 1. So that's another way that we could have just attempted this one. So we calculate the adjacent side as we are going to need it on the cos. Cos is adjacent over what? Hypotenuse. So we must have that adjacent. From our Pythagoras theorem, we can see that these are the x value, these are the y values, and that's our r, the r squared equal to x squared plus y squared. That's 1 squared is equal to, we need the x given the y value as what? As m, so that's m squared. So we're going to take this to the other side. That is going to be 1 minus m squared equal to x squared. So introducing the square root, our x is equal to the square root of 1 minus m squared, which must be what? Which must be positive side. So that must remain as a positive, all right? We are on the positive side. So we have calculated the adjacent side. So it'll be easier for you to calculate the cos of what? The cos of 36 degrees, as we do understand cos is what? Adjacent over the hypotenuse. So that will be our adjacent, which is the square root of 1 minus m squared over hypotenuse, which is what? Which is 1. So divide here, it was going to be 1 minus m squared under the square root. So this is our cos 36 degrees. We can also use that concept if you do understand it in a better way. That was going to be the best to attempt this question. All right, then we are going to consider another question which was a little bit complicated, which is also good as we are having our revisions also to understand all the basics in our revision, which is question 5.2. On question 5.2, it was just issue of understanding our basics. So if we do understand every basic here, it was going to be easier to attempt this question. Okay, everything is visible here. I'm not gonna rewrite, but we are asked here to show that the left-hand side must be equal to the right-hand side. So you are going to take your left-hand side. So here there's no way I have to just rewrite, which is -2, the sine of what? 15 degrees cos 15 degrees, everything over, that is cos of 45 degrees minus x, all right, times the cos of x minus, so this is the minus to subtract two terms. So this is a single term, and this here is a single term again. So that is the sine of what? 45 degrees minus x times the sine of what? The sine of x. This is our left-hand side, which must give us the right-hand side. So on the left-hand side, they tried to hide some of the identities. So like I said, there are so many ways. I'm going to use this one. If you check 2 sine cos, it is part of your identities. This is your grade 12 mathematics. Remember, I talked about these identities that you must be able to figure them out. So what are we given there? If you have forgotten, the formula sheet is there. Let us go to the formula sheet and see that concept. The sine, 2 sine, and there is a cos. 2 sine 15 degrees cos 15 degrees, because this is the same angle, alpha alpha. Where is it taken from? It is taken from the sine of what? 2 alpha. It is taken from the sine of 2 alpha to give us that part that we see there. The sine of 2 alpha is stating that it must be 2 sine of alpha cos of what? Alpha, which is 15 degrees here. This is what we have. This is 15 degrees. This is also 15 degrees. So giving this, rewriting this back here, it is supposed to give us what? The sine. This whole thing here is going to give us the sine of 2 times alpha. Our alpha is 15 degrees. So 2 times 15 is what? 30 degrees. That is the sine of 30 degrees. So this whole part is going to give us sine of 30. But remember, there is a minus there which is given. So that's minus the sine of what? 30 degrees. Also, they tried to confuse us in the denominator, from which identity. Look what is happening. Cos 45 minus x, sine 45 minus x. It is telling us that this represents one angle. It's a single term, this one. It's a single angle, this one. The same thing, meaning to say they are the same, this one. So it is like cos A sine A, or cos alpha sine alpha. Then there is a cos with x. There is a sine with x. Same angles again. Just like cos beta, sine beta. Do we have something of that nature, guys? Do we have something of this nature from our identities, where we have got, because this one we're taking it as alpha, this one as what? As beta, this one as alpha, as beta, because they are the same. Do we have something like that? Cos alpha, cos beta, minus the sine of what? The sine of alpha, the sine of beta. Do we have that concept in our identities? Yes. The cos of alpha, cos of beta, minus the sine of alpha, sine of beta, was taken from our compound angle identities of cos alpha plus beta. It was taken from there. So if it was taken from cos alpha plus beta, guys, just use it. Just use as it is. This was taken from what? Cos of alpha plus. Take note. So if we have given this as 45, our alpha is what? Our alpha is 45 degrees minus x. So in place of that, it is going to be cos alpha 45 degrees minus x plus the beta, which is what? The x. According to what we are given. Like this. So this is what you're going to have at the end, which is cos of what? Minus x plus x, that is what? 45 degrees. So guys, you see, they try to play around with you, guys. They play around with your mind. It's exam time. It's exam. Expect you to know everything that you've done before. So as you can see, when it is like this, isn't it easier, guys, to simplify than that complicated thing that was like, what is it that I'm working with here? It's not that complicated. Use your identities where it is applicable. So with this, I can simply use my special angles. Remember, from the 30 degrees of which there's nothing special here, because we can even use our calculators. Remember, that's 60 degrees. That's going to be 30 degrees. This is 1, 2, square root of 3. So the sine of 30 can be determined. Remember your SOHCAHTOA concept. SOHCAHTOA, opposite over hypotenuse. So sine of 30 degrees is the opposite over the hypotenuse. 1 over what? 1 over 2. To determine the cos of 45 degrees from our special angles, that will be 45 here. This will be 45. This is 1 square root of 2. These ones, according to your syllabus, you can even memorize them. So that's why I'm saying there's nothing special about our special angles, because someone can even know these ones by head. Cos 45, it's 1 over square root of 2, which is square root of 2 over 2. Guys, yeah, cos 60, it's 1 over 2. I just need to know these ones. Guys, by head, memorizing, knowing, you can know these ones. So there's nothing special here. Adjacent over hypotenuse, 1 over the square root of 2. But remember that 1 over square root of 2 is the same as what? Square root of 2 over 2, which your calculator gives you in a simplified manner if we rationalize our denominator. So it's going to be square root of 2 over square root of 2 multiplied to 1 over square root of 2. So that will be square root of 2 over this one times this one, which is what? Which is 2 in simplest form. Or just use your calculator there. So with this, we can substitute our values representing these two. The sine of 30 degrees, 1 over 2. Divided to the cos of what? 45 degrees, which is the square root of 2 over 2. Remember the division concept when it is to be applicable, that I am dividing a fraction to another one. I have a fraction in this case of minus 1 over 2 divided to this. I can even write divided to square root of 2 over 2. It is the same as minus 1 over 2 times. The moment I multiply, I do change these. So it's going to be 2 over the square root of 2. So that is it. These ones can cancel from the numerator denominator concept. So that's minus 1 times 1, which is minus 1. 1 times square root of 2, that's square root of 2. But that's not the answer that we're given. We have to rationalize, which is the same thing that we did here to say 1 over square root of 2. It's the square root of 2 over 2. Remember, I mentioned, okay, it's only that I have removed it, but you know where it came from. So it's going to be square root of 2 over 2 with what? With a negative. Minus square root of 2 over 2 with a negative. And that's exactly what we are given on the right-hand side. That's exactly what we are given on the right-hand side. So this one is just simplification now. The exact part was here. Use of identities. Know your identities, guys. Know your identities. There is no way. Know them. Okay, no problem. Maybe you did not notice that. You didn't notice that. But maybe somehow you noticed the sign of what? The 2 sine 15 cos 15, because somehow 15 degrees, it's going to be from half angles. You can use those ones from half angles to calculate sine 15 and cos 15. Guys, it's going to be complicated. Remember our special angles: 30, 45, 60, 90, and 0. So, meaning to say, when it is 15, it's going to be complicated. So maybe you realized that this here is equivalent to sine 30, as we saw before, because 15 degrees is actually a complicated angle to work with. So definitely on the one that is on top, you are going to be limited to the same way that we simplified up to when we got sine 30. So on top, there was no way. You're going to obtain negative sine of 30 because you want to avoid these angles. But in the denominator, maybe you couldn't realize the concept to say that here can give us what? A compound, or it is taken from a compound angle identity. Then you choose to expand this one now. Direct the cos of 45 minus x. You choose now to expand it direct. Meaning to say you're going back to the cos here. Where is our negative? This one. The cos of alpha minus beta. This is the one that you're going to use to expand cos 45 degrees minus x. So guys, as you can see, where there's alpha, it's going to be 45. This one is going to be x. This one is going to be 45. This is going to be x. So that is how you're going to expand it. All right. So I want you to take that answer and put it here. So it was going to give us cos 45. Remember cos, the sign changes. Cos 45, cos of x, the sign changes to a plus. Sine, same angle, 45. Same angle here, sine x. So it's sine. But everything is being multiplied by the what? The cos of x, which is outside. That was another way, times the cos of x. Then we do the same thing, minus sine 45 degrees minus x. You do the same thing, you expand sine 45 alpha minus beta. So this is 45 degrees minus x. So this was going to be 45 degrees. This was going to be x. This was going to be 45. This was going to be x. So expand it that way. Cos sine, sine cos, cosine, sine, then cos, all right, like that. So you're going to expand. So it was going to give us the sine of what? 45 degrees, sine, as it is there, 45 degrees, then cos of x. All right, the negative remains as it is. We saw that. Then it changes now. You started with a sine, it changes to a cos. So it's going to be cos of what? 45 degrees. The sine of what? The sine of x. It changes. You take that identity as it is times the sine of x. That's another way. But as you can see, it's going to be a lengthy calculation. It's going to be a lengthy calculation here. These angles, guys, we have already simplified. I'm not going to redo this. We talked about how to find sine minus 30 from your special angles. So it was going to give you, we are going to simplify it. All right, and give us minus half. So that's minus half, as we have got this fraction, cos 45. Also, I'm not going to simplify it. I talked about this before. But you see from that triangle, cos 45 degrees and sine 45, they're exactly the same. It's from the same ratio, same answer. So, not from the same ratio, but the values that you're going to have there on that triangle are the same. So, that is it, guys. So, meaning to say cos 45, we simplify this. We said what? Square root of 2 over 2 in simplest form. Yes, you can use 1 over square root of 2. Here I'm just writing in simplest form, times cos x plus sine 45, same as cos 45, square root of 2 over 2 times the sine of x, which is outside. Then everything in this bracket is affected by what? The cos of x. So we have simplified it, minus the sine of 45 is the same as the cos of 45, square root of 2 over 2 times cos x minus cos of 45, square root of 2 over 2 times what? The sine of what? X. Then we multiply by the sine of x outside, this one. All right? So this is it. We simplify, guys, as we are to simplify the denominator. The numerator is not affected. It's just going to remain as it is. So on the numerator, minus 1 over 2 is going to remain. But the denominator now, we can expand here by cos inside. So distribute by cos. Cos is going to multiply cos. It's going to multiply sine here. So that's cos times cos, which is cos squared. Square root of 2 over 2, cos squared of x. All right. Then here plus square root of 2 over 2 sine x times cos, which is sine cos. There, as we multiply, do not forget the negative. So you take this as a single term, negative and sine of x. All right. So it's negative and sine of x at the same time, multiplying cos. So it's going to be negative square root of 2 over 2 sine x cos x. The negative has to affect again. Here it's negative to negative, which is what? Positive. So it changes to positive. Square root of 2 over 2. Then we multiply sine and sine, which is what? Sine squared of x. As you distribute, do not forget the negative that is outside of the what? Outside of the bracket. So with this, we can see that the two terms here can cancel because they are the same. Sine x, cos x, these are like terms. So we can cancel those two. There is something here. They are exactly the same. Their coefficients are exactly the same. So that's why I'm saying simply cancel that. So you're left with this one and this one, where we can see that the square root of 2 is what is common. So we can factor it out. Remember, this one is no longer there. So we can factor out the square root of 2 over 2 to what is remaining. So this is it, minus 1 over 2 over what? The square root of 2, which is common, factor it out. Square root of 2 over 2. You remain with what? If we factor it out from cos squared, it's going to be cos squared of x. What are we going to remain with here? Plus sine squared. of x. Remember your Pythagorean identity. Cos squared plus sine squared gives us a 1. So multiply it to this. It is going to be minus 1 over 2 over what? The square root of 2 over 2. Just like the previous case where we have got a fraction here, a fraction there, and we saw that when we simplify this, it is going to give us negative square root of 2 over 2. We had this one before. So we ended up with minus square root of 2 over 2. So that was it. That is how we can simplify this question. So many ways, but you just have to choose which one is easier. So I do not know, guys. The comment section is there so that we communicate where you do not understand. And also, as part of membership, you can join membership so that you'll be able to ask any of the questions that you feel like you do not even understand or you do not have an idea on. You can try to work on that one. So that is it, guys. As you can see, there will be questions direct. There will be questions that are direct, but it is now in your hands. How are you going to answer? You as an individual. That is it. All right. 5.3, which is we are given a piece of land is the form of a quadrilateral ABCD. This is the piece of land. Given AB as 20 meters, BC 12 meters, CD 7, angle B 110 here, and angle CDA is what? 71 degrees. The owner decides to divide the land into two plots by erecting a fence from A to C, so that there is a plot here and a plot there. All right. So this is what we are given. From that information, they are saying calculate 5.31, the length of the fence AC. They are simply saying calculate AC there. Correct to 1 decimal place. All right. So how can we calculate AC? If we check properly, we can see that in a triangle ABC, the information provided actually is enough, guys. This is our cosine rule in triangle ABC. We can use the cosine rule as we are given two sides and an included angle. B is an included angle. Remember, calculating the third side from the cosine rule. That is the condition. So the cosine rule, guys, do not worry about this because you are given the formula. In your formula sheet, you have the formula. So learn to adjust that. The formula is just straightforward. A squared is equal to B squared, this and that. What does it mean? What is the meaning of what is given there? When they say A squared is equal to B squared plus C squared minus 2BC cos of A. What is important is the meaning of this part. A is the side to be calculated, which is our AC. So AC squared is equal to B and C are the other two sides you are given, which in our case is side AB and BC. The two sides. And those are the two sides again that you are subtracting as 2BC. So it's two times those sides that you're given, AB and what? AB and BC times the cos of what? A, the angle opposite to the side that you're calculating A, this one, the angle opposite to the side you're calculating, which is your included angle. That is the case. So it's cos of what? ABC, angle ABC or angle B. That is our cosine rule. Know your formulas, guys. Know your formulas. It's not about just the formula. Interpreting of the formula, understanding the formula. So that is it. We can calculate our AC. So that's AC squared is equal to AB squared. We square this. 20 squared plus BC squared, 12 squared minus 2 times those two sides, A and B, combined. That's 2 times 20 times what? Times 12 times the cos of the angle, our included angle, the angle opposite to the side that you're calculating, 110 degrees. So with this, AC squared was going to be determined. You can use your calculator to simplify everything at once. You can simplify these two. That was going to give us something like 544 minus, you multiply this, you're going to get 480 cos 110 degrees, and just use your calculator to simplify everything at once. 544 minus 480 cos what? 110. So this was going to give us 70, this and that, 708,169, and so on and so on. This is what you have from your calculator. Just leave it as it is. From those values as they are on your calculator, introduce the square root to determine the exact value of AC. Square root of the answer is what? 26.6 to 1 decimal place as we are given. 26.6. 1 cannot change 6, guys. So that's 26.6 in meters. The units in our case are given in what? In meters. You follow the instruction correct to 1 decimal place on 5.31. All right, that was 1 decimal place. I was like, what is happening? Where am I seeing 2 decimal places? The 2 decimal places on the other one. The 5 point what? The 5.32. Just like that, guys. You see these questions, they are just like, guys, these questions, they are direct, guys. They are direct, you see. The size of DAC as an angle. So it depends now. You can use the stored value. This one, you can store it. Shift store at A. Then you use the stored value, or you can use the rounded off value. All right. So that is up to you. Using the rounded off value, we can see that AC is there. We have it now in this concept. We've got our AC as 26.6 meters to 1 decimal place. So the question now on 5.3 is to calculate DAC. DAC, the angle that is formed at A. The angle formed at A. So how can I determine that angle? This is our sine rule, guys. An angle corresponding to a side. An angle given corresponding to a side again. Once this happens, that the angle corresponds to the side, use your sine rule. As it is in your formula sheet, it states that A over sine A is this over this. Like I said, this can be written on top if you want to calculate angles. Sine of A over A is what? Sine of B over B, like that. It is simply the same. Which is the same as what? Sine is C over C. If you're calculating angles, it's best that you write those angles on top. Yes, it is one and the same formula. Even if you do not want to change, guys, even if you do not want to change, just use what you understand. It's mathematics, guys. At the end, it's mathematics. All right. So what does it mean here? The sine of A, the sine of the angle to be calculated, DAC over the corresponding side. So DAC corresponds to what? To 26.6, the one that we calculate. Guys, look what DAC. This is DAC, this one. This is A. DAC, it corresponds to 7. All right, so it's over 7 there. Sorry for that. Sorry for that, guys. Over 7. This must be equal to what? The sine of the corresponding. It must be angle to the side. Angle to the side. Corresponding angle and side, which is complete. So D and this 26.6 is complete. So we are going to use the sine of the angle at D, 71 degrees, over its corresponding side, 26.6. This is where I said you can use the exact value which is in your calculator, the one that you stored at A, or you can use the rounded off value. They are going to mark you for that one. Do not worry. So you can even maintain this times 7 to get rid of this 7 in the denominator, so that we can calculate the sine of DAC as this one. You're just going to multiply this, just write 7 times the sine of 71 over what? 26.6, of which you can just simplify we could have just simplified this one direct on our calculator. The sign of what? All right, 7 sine 71. 7 sine 71 degrees over what? Over 26.6. Or you can use the exact value. If you want to use the exact value, this is what you do. Recall, you press where you stored. It's either A, B, C. So recall A. This is the exact value because I had to use the stored value. 0.24 and so on and so on and so on. Okay? So to find DAC, which is the angle from sine, you must determine arcsine of this answer on your calculator, arcsine. So it's shift, you press sine like that. So arcsine of our answer is 14,4, 0, 1, 14,40, 14. 401 and so on. So to two decimal places, guys, one is not going to change that. It's going to be 14,40. All right, that is what you are going to have in this case. But now take a closer look. Here we used the stored value, the one that we stored, the exact value. The stored value is the exact value. This one is just for a presentation, but when you calculate, use the exact one. So if you used this, the rounded off value, this is what you're going to get. If let's say we used the rounded value, it was going to be 7. We're going to have it like this: 7 sine 71 like this over what? 26,6 as the rounded off value, like this one. So you're going to get this. Then it's shift sine, which is arcsine of your answer, which is 14, so this one now was going to give us 14,41. If we round off to two decimal places, it was going to be 14,41. If you used the rounded off value, your answer was going to be 14,41, which is okay like that. Use it as it is. So this is how these questions are given. Do revise. Do revise as many questions as you can. Prepare yourselves, guys, for the exams that are ahead of time. You must know all the basics in your syllabus for your term 1 as you are dealing with the March test. So like I said, it also depends with the province that you are from. Some provinces are going to give you the questions on algebra. Revise your algebra, guys. Revise it, all right? So for you to be able to download the question papers, if you check here, this is our Maths Zone African Motives page on YouTube. You search Maths Zone African Motives. Then if you enter here, you are going to visit the community. Visit communities for those who want to send their questions. Let's say there's a question that you want to send. Press that visit community. You can be able to upload any question of your choice. It's a picture. You can take a picture. You upload it as a picture like that so that I can be able to work on that one, image, whatever that you want. I don't know, whatever that you want there is, this is what you can do. All right. So work out with the membership, with the community section in order for you to send those questions that you feel like they are challenging. That way we can be able to help each other. But as of the questions now, if you get back here, let's go back now. Where's my back? Let me see. All right, it's only that this is all right. I want here, sorry guys, let's just go to the Maths Zone African Motives here. So this is what you do on this YouTube. There are links here. They're saying this one, and the links, it depends with the, are you using the laptop, TV, phone, or what? But if you're using your phone or laptop, that's, you can download these PDFs. This is where you go. You press this link. All right, you just not the link actually, but this way it is written, and more. You press it. All right, so it's gonna show you other links which are there. All right, there are WhatsApp groups. It wanna depend, and if you check, there are these ones with the drive. This one, mathematics grade 12. All right, you go to the mathematics grade 12. Press that drive. So in this drive, it is the drive which is meant for you guys for mathematics grade 12. This one. This is your drive. Don't go around to search things that are not meant for you, guys. I'm giving you this platform for you to use it only for your question papers or for anything that is meant for mathematics grade 12 and any other thing that we are going to add later on for your grade 12 studies. All right. So focus on that. I don't know if we are going to maybe just write it grade 12, then inside it we put mathematics, physics, geography, everything. So I'm going to see how it is going to look like later on. Maybe later on when we check this video, it will be edited. That drive maybe to be just showing it as what? As grade 12. Whatever that it will be showing, but it is going to show you that it's for grade 12. All right. So you go through this drive. There are things, there are textbooks, there are question papers. These are the ones that I have. So if there's anything that I get, I'm going to add it on the drive. So you can go through that, check whatever that you want, download, because I have given you guys the access to download anything. Like for an example, I can press here. This is KZN 2015. This is Gauteng 2019 September. So you can even edit them on your side. After you download, you can edit that one. Do not edit on the drive because it will affect others. Edit on your side. All right, you download it, then you edit on your side. Here I gave you the platform for you to download these question paper. All of these you can be able to download as you are part of Maison. Even if you are not part of Maison African Motives, as long you have the link, you can download these question papers. All right, so let's say I just want one question paper, or maybe it's mathematics paper 1 November 2022, or whatever that I want. I can click it direct, or I can come to these three dots, more action. On those three dots, it's gonna tell me here download. All right, so here, because I'm the one that is on my side, the owner, it can tell me to share. All right, this is, no, I'm not using, there's another account, this one. So it can say share. You can even copy a link and share to your classmates. All right, copy that link, share to your classmates. They can learn from that. For you to download, the download is there on top here. So you can see that the download here, let me just indicate. All right, it's only that if I put this one, I don't know if you see that download. All right, so you see the three dots, press the three dots, you press what? Download. Okay, why is it doing like this now? All right, download, like that. So depending with the phone or whatever that you're having, now on my side is scanning for what? For virus before it downloads. So it can even scan for the virus before it downloads. So after it is downloaded, as we can see, this is what we have. It is downloaded. So you'll be having this now on your machine. You'll be having this in your phone, any device besides for a TV. But if you are using your desktop, you are using your laptop, you are using your phone, you'll be able to download it. So you can even go back and check for the memo. Sorry for that. It was here. You can even go back. As you can see, they are in order. The memo is already there, marking guideline, the one that is following. So I can even click it, click this one, download. I'm now downloading what? The marking guideline. So we have these question papers, we have got the memos, we've got everything. Here on YouTube, we are here, guys, to teach you the knowledge that is necessary behind the memo. Guys, we have got these memos. Okay, will give you everything, but does not help if you do not understand what is in your memo. Does not help. So that is why we are having this provision of our classes as part of YouTube classes and as part of membership. Join membership so that you do not miss any of the other explanations that are important as you prepare yourselves for the exams that are ahead of time.